All right, so welcome back. Welcome back to the channel. So in the last video, we have learned about flash attention, right? Faster attention. How can we do faster language modeling? How can we train faster? How can we train language models in a very faster way? We have learned about bunch of methods such as tiling and I don't know it is tiling or tiling, but uh, tiling and recomputation, right? We have looked at some methods that we could use. And we have elaborated on one point that we should decrease the amount of HBM accesses and increase the computations because, of course, modern GPUs are better at computation. So in this video, I just thought of just going through the code, maybe just on a very high level, just going through the code and also just try to understand what each file is doing and each function is doing. Uh, I will just go through the code. So I think I will provide the code. So this is the official implementation. This is the official implementation of Flash attention. This is the official implementation of Flash attention. There are a lot of files. There are a lot of files. I actually thought of just maybe like implement it on a real attention model. Maybe build a real language or train a real language model using this. Uh, but I just thought and or you know what, maybe we'll just do that in one of the future videos. Maybe we'll try to implement flash attention in a separate language model. Maybe we'll train a language model using flash attention maybe in the future, because I don't even have a GPU. So I mean, definitely if you have a GPU, if you are capable of buying GPU, definitely that would be good. Or maybe I'll try to run it on Google Colab or something. So for this video, we are just going to go to the intuitional parts, so the main intuitional parts. So this is the code. Uh, the creator of Flash Attention is this man. I can pronounce the name. Uh, so he is the creator of Flash Attention. So and I think he works at Stanford or something. Yeah, he works at Stanford as I think a professor. So we'll just go through the code. So the main file folder, of course, is Flash Attention. So once you get into this Flash Attention folder, subfolder that belongs to this Flash Attention, of course, the repository, you have bunch of files saying having different names. Flash Attention. I think you might understand some file names, at least some file names, right? Bird padding, you know, something that is related to bird modeling, and Flash Attention interface. Maybe something like the background models of Flash Attention. And these two names, don't worry about them. Triton is nothing but we have CUDA and all that, right? When we're doing like neural network programming, we have bunch of libraries like CUDA, which we could use to like implement or train different language models or and use these GPU capacities. So Triton is just something like that. We could just use these capacities for like faster computation. So there are like bunch of computational libraries inside Triton and CUDA, of course. So you could just use them to perform different operations like attention and all that, which makes these algorithms run faster, right? So we'll just use CUDA in one thing. I think we'll just use CUDA in maybe this one or something, and then we'll also use Triton, right? And we also have like Flash block sparse attention, about it, using block sparsing, removing the unnecessary parts, and also this interface, the background models. So I think so. We'll just look at what these files actually are. Let's open some of them. So this is the bird padding, they say. Yeah, so there is so this is all about like tokenizing and all that, the pre-processing, the data pre-processing. So not about modeling, I think. Yeah, so essentially like tokenizing the letters, or we just tokenizing the text, just converting into a numerical representation. So this is the interface, the Flash Attention interface. We have a bunch of functions, let's say. So this is the Flash Attention forward function, the main forward function. And as you can observe here, we are not using like we are not writing like commands. We're not writing one by we are not writing commands one by line by line, right? We are not multiplying them. We are not performing softmax, right? We are not multiplying by we are not doing anything line by line. We have a function here which is flat attention CUDA. Again, we are using CUDA here, dot forward. So I think this is a function inside CUDA, right, through which we could just use the CUDA implementation of attention, through which we could of course use the we could just use these models very fastly. So that is the idea. And I think here we have like variable length, I think. So that's something that changes or something. Yeah, so this is also like the forward layer, but here, yeah, so that's it. Yeah, so yeah, so here we have, I think, what is varlen? I think it is length, variable length. I think maybe the length changes or all that. And then we have the backward function. Again, we will use the CUDA dot backward BWD on these variables, of course, on these variables, taking the DQ, DK, and all that. And then so this is the packed function. I think everything for packed. And then the backward, and there is a there we'll call the backward function and all that. So we will call the previous backward function inside this backward function, and we'll call this forward from the previous forward and all that. So of course there is a lot of lines. You can just go through it if you want to, but the main goal of this video is just understand the basic overall function. Like if you want to like go through the code, just go through it by yourself, or just there are a lot of lines of code. If you're really interested, then I would maybe suggest you to go to the code. If not, then maybe we'll just use it in the next video or something. So as you can see here, so this is the interface, building the interface, the flash attention interface. Of course, we have so the one main thing that we should take away from this file is that we are not performing operations one by line, but we are using CUDA functions, the CUDA pre-built activation functions or pre-built attention functions. It not activation function, it's attention functions. So we'll just use them to like perform the forward and the backward pass of the attention. Right, so that is the first main file, I believe. And here this is like the same implementation, but in using Triton. I think they'll just use Triton rather than just that. I think I think it is equal. I think both the things do the same. I'll just look at let's say the comments. So this is an experimental implementation. The forward charge pass should be quite robust, but I'm not 100% this condition today. Yeah, so this is just like a alternative to the CUDA version using something called Triton. So this is something this is the main web page of Triton, open source GPU programming for neural networks, just like CUDA. Right, so this is like this is the one other function or one other library you could use for GPU programming. And then we have block sparse attention. You all know it. We are just going to like select a particular. We're going to select like particular parts of the attention of. We are going to only select like some blocks and perform attention on them. Right. We'll have attention mask. Right. We'll just add this attention mask, and then so and yeah, and then basically we'll just call this function. Yeah, so yeah, we have this. This is the main class, right? We'll just carry the forward function in which we will yeah. So basically, we'll just perform the flash block sparse attention function. I think we have got that from the interface function, interface file. Yeah. So from the interface, from the flash attention dot flash block sparse attention interface, we have already implemented this function, flash block sparse interface. So we'll just call that pre-built function in this file, and then and then also we have like I think another version. for like multi-headed addition. Yeah, we have the final layer, linear layer. We'll perform the, yeah. So we just calculate. Yeah, we have just like the classic addition. Now we'll just create a random vector. We'll pass that through a linear layer. Get the q w q. We'll get the q k and v. We'll pass that through flash box pass attention and get the linear representation, and or the linear output projection, and that's it, right? So that's it for flash box pass attention. So I just you know we have, I think you could just look at all of these files and just at least look at some similarities uh, with what we have actually learned. And to be honest, we haven't actually understand everything clearly. Still, there is a lot to learn about flash attention. I think still like there is lots of code that we cannot understand, right? um there's like we should do some more research on this, but I think for now this is, I think, a pretty good understanding. Yeah, I mean, pretty good basic introductory level understanding of flash attention, how to actually use it, and how it works and all that, and the implementation. uh I think that's it for this video. And also I just want to show you one more file, right? So they have like, I think the I mean, almost, I think I hope all of you have experimented or built a language model using PyTorch transformer. So even if you are like fan of TensorFlow, you've like a lot of language models are generally built using PyTorch. So the NN transformer, the PyTorch transformer, has integrated flash addition in its PyTorch NN transformer. So so the next time you are building transformer using like PyTorch transformer NN transformer function or function import, whenever you import this, remember that you are using flash attention for the computation. So PyTorch actually integrated this uh, flash attention, and also Hugging Face transformers library. They have also integrated it. Microsoft Deep Speed, Megatron LM, Compose library, and GPT Neo. Uh, and I think it's a very good thing that I think this is a pretty good breakthrough in language modeling. Flash attention is, and even like, I think maybe we could train models, train language models, and if you have any GPUs, and I think maybe in the future, right? Uh, our our computers will get much faster, and maybe more research will go on speeding up language models, right? Then we could actually, I think, we could train a huge language model on our simple computers maybe in the future. So yes, so that's it for this video. I just want to make this video as like very, very introductory. And yeah, so maybe in the future we'll just go through much of this flash edition. I think that's it, the basics for now. So thank you for watching. I'll see you in the next one.